Welcome to this explainer, where we're going to take your backyard harvest from, well, a frustrating game of guessing, straight into an exact science. If you've ever felt like your garden is a complete mystery that you just can't seem to solve, you are in the exact right place. Today, we're digging into the science of soil testing.
Look, we've all been there, right? You water like clockwork, you pull every single weed in sight, you're out there sweating in the hot sun, and yet, puny tomatoes, sad, struggling peppers. It's incredibly frustrating. But why does it actually happen? Well, more often than not, it's what you can't see. Invisible soil deficiencies are usually the real culprit here, and you can't fix what you can't see, right?
Okay, let's dive into this. Here is our game plan for today. First, why test your soil at all? Then we'll go through a step-by-step sampling guide. After that, we'll decode the nutrient availability index. And finally, we'll look at the absolute power of soil pH. So, Section 1. Why test your soil? Think of it as your garden's health checkup.
You wouldn't just guess your blood pressure, right? Same goes for your garden. Before you even think about planting a seed, a routine soil test gives you the actual data. It estimates the hidden supply of plant food already sitting down there in the dirt. It tells you if your pH is off, and best of all, it gives you precise, tailored recommendations for fertilizer and lime. So instead of just tossing generic fertilizer on the ground and crossing your fingers, which, let's be honest, wastes a ton of money, you're using data. That is the true secret to massive tomatoes and healthy peppers. Moving right along to Section 2, the step-by-step sampling guide, or as I like to call it, the field work.
This is where you get to put on your gardening gloves and be the lead scientist of your own backyard. It's wonderfully straightforward, but accuracy is everything here. Step 1, gently rake away any surface mulch, straw, or old leaves. You want to expose the bare dirt. Step 2 is absolutely crucial. For backyard veggie gardens, you need to dig down exactly 4 inches. Not 6 inches like they do for commercial crop fields, just 4. Step 3, grab a small core of that soil and pop it into a clean bucket. And Step 4, you're going to repeat this process all over the growing area.
And you really shouldn't just grab a single scoop from one spot and call it a day. You want to take soil from about 12 to 14 random points using a zigzag pattern across the entire bed. Why? Because it guarantees your final batch is a true, accurate representation of the whole garden. Remember, the fertilizer recommendations you get back from the lab are literally only as good as the sample you send them.
All right, so you've got your 12 to 14 cores in the bucket. Now give it a really thorough mix. Toss out any rocks, gravel, or roots you find in there. Once it's all mixed up, spread it out on a clean surface, like some newspaper on a workbench, and let it air dry. And guys, a major warning from the experts here. You must let it dry naturally in the open air. Do not, I repeat, do not try to speed this up by sticking the dirt in your oven.
To wrap up the fieldwork, once that soil is perfectly mixed and completely bone dry, you just scoop out exactly 1 pint for the lab. Put it in a designated little container, which you can usually grab right from your local extension office, label it up clearly, and drop it off. Boom, your physical labor is officially done.
Okay, Section 3, decoding the nutrient availability index. Time for the translation phase. So, the lab sends back your report card, and it is usually covered in scientific jargon. We're going to demystify that right now. You're going to see a lot of numbers with ppm next to them, which stands for parts per million. But what does that literally mean for your backyard? Well, it's a measurement of concentration. To visualize the physical scale of this, 1 part per million equals roughly 2 pounds of that specific nutrient spread over an entire acre in the top 6 inches of soil. So if your report says you have 50 ppm of something, that's essentially 100 pounds of it per acre. Kind of mind-blowing when you scale it up, right? Let's move on and see how this builds into the nutrient availability index. Right next to those ppm numbers, you'll see a classification ranging from very low all the way up to optimum. This index is basically a crystal ball for your garden. It actually predicts your crop yield potential before you even apply a single drop of fertilizer. If you hit optimum, you're golden. You can expect a 100% yield potential without adding any extra fertilization. But if you fall into very low, low, or medium, your yield will be suboptimum, and the lab will tell you exactly how much fertilizer you need to bridge that gap. And here's a crazy comparison that really puts things into perspective. Take phosphorus, for example. For standard row crops, out in a farm field, if the soil is at 36 ppm, they generally don't even need extra fertilizer. But backyard vegetable crops, they need a baseline of greater than 75 ppm. It just perfectly highlights that backyard veggies are incredibly hungry, demanding plants. They require a way higher nutrient baseline than your average field crop.
Which brings us to Section 4, the power of soil pH. This is the absolute foundation of your garden.
Think of soil pH as the invisible gatekeeper of your soil. It literally dictates whether your plant roots can even absorb all those expensive nutrients we just measured. So the absolute crucial point here is this specific sweet spot, 5.8 to 6.5. That is the magic range for most vegetable crops. If your soil gets too acidic or too alkaline, those nutrients get chemically tied up, meaning your plants could literally starve to death in soil that is packed with food, all because the pH is off.
And you really have to respect the math here, because the pH scale is super sneaky. It's logarithmic. That means every single whole number change is actually a tenfold difference. A tenfold difference. So if your soil pH drops from a perfectly healthy 6.2 down to a 5.2, it's not just a little more acidic. It is 10 times more acidic. Even a tiny shift in that number represents a massive chemical earthquake for your soil, which severely impacts how your vegetables grow.
But hey, don't panic. The beauty of the lab report is that it hands you the exact actionable fix to correct that invisible foundation. If your dirt is too acidic and you need to bump that pH up, they're generally going to tell you to add lime. On the flip side, if it's too alkaline and you need to bring it down, you'll be looking at adding elemental sulfur or aluminum sulfate. No guesswork, just tailored instructions to unlock your soil's true capability.
So, I'll leave you with this one very important question. What secrets is your soil hiding right now? Seriously, it's time to stop guessing and start testing. I hope this explainer showed you that taking control of your garden's chemistry is totally accessible for us backyard growers. Now it's time to grab a shovel, hit the dirt, do that zigzag walk, and finally unlock your garden's true scientific potential. Thank you so much for joining me today.